All right, guys. So, just like you did, I took this piece of folder, I cut out a nice triangle, I carefully balanced it on the tip of my compass as best as I could. I didn't want to, you can't really do it perfectly, but you do the best you can. I poked a little hole in the paper where it seemed to balance the best. I marked it with this dot. Now we want to see if we can figure out what the nature of this dot, this center point is that we call the centroid, where the triangle balances. So what I want you to do is take a straight edge and line it up with a vertex on the triangle and also with this centroid. Centroid. And draw the line. And then go to another vertex. So do the same thing. The distance thing. Well, we'll see what it is. Now this, we're constructing a point of concurrency, but it's not much of a stunt because we just said draw 3 lines that go through the centroid. We can't help but end up with a point of concurrency. So we're going at it a little backwards from what we did before, where we had some rule for drawing these lines and they turned out to go through the same point. Now we're making them go through the same point and we want to see what kind of lines these are. So you've got these 3 line segments in your triangle, all 3 coming from the vertex, 3 vertices going through the centroid. What are they? Are they altitudes? Well, if it's an altitude, it has to be perpendicular to the side. So this one clearly isn't perpendicular. Ah, angle bisectors. So we can test that. If you think you've got an angle bisector, you could do this.
If you interview the principal, would actually interview the principal.
Now look at this angle. Kian. Josh. Look at this angle. Many people will say these are all angle bisectors. Look at this one. Does it look like it's bisecting that angle?
No.
Do I really even have to measure that?
No.
I'd say no. I don't think that's an angle bisector. What are the other possibilities? Oh, medians. So if it were a median, what would be true?
It would be an angle. It would be half the side.
Half of the side, the midpoint of the side. So I could check that with my compass. I can put my point here, measure that. Very close. Yes?
Yeah. Probably.
JJ?
Because you could be a little bit off.
We all know that I wasn't perfect about balancing the triangle any more than you were. So try this one. Ooh, that is really good. That's a perfect match. Now I'll try this big one. Pretty darn good. I'm very happy with that. So these are all medians. Yeah. Now if we look at our conjecture page, maybe there's something about this. Have a look-see. C14, the median concurrency conjecture. Now, like I said, we really did this backwards. We should have taken a whole bunch of triangles in this room and done medians for all of them and seen if they all met at a point of concurrency. We did it backwards. I made sure that it's a point of concurrency, and this one turned out to be a set of medians. You, looking at your triangle, should also see that they appear to be medians, or nearly so. What do you think? Anybody just find something way off? Medians? Did you draw the medians?
I'm drawing it down.
Okay.
Wait, Carmen, can I have my ruler back?
This is the wrong, this is the right one.
Look, she don't have to cut it out, so don't jab it. You wreck her.
Triangle, never had any potential, Josh.
What?
How would you move this?
So, conjecture 14. The three medians of a triangle are concurrent, yeah.
Wait.
Like I said, we did this backwards, but it's still the same punchline. Then I go down to C16. C16, the center of gravity conjecture. The blank of a triangle is the center of gravity of the triangular region.
Centroid.
Very good. Centroid. All right, now. Conjecture 15. What do you think? Centroid of a triangle divides each median into two parts, so that the distance from the centroid to the vertex is blank the distance from the centroid to the midpoint of the opposite side. So if it's equidistant, it's saying that this is the same as that.
No.
Not true. What else do you suppose it could be?
The bird. It's
Half.
Half. Well, let's try doing that. Let's take this and I'll copy it, see if it goes in twice. Nicely.
really?
Yep. And we'll do this and see if it copies in. Did I get that right? Keeping in mind, this is not a perfect centroid construction. Pretty close. And we'll try this one. Perfectly. So, centroid of a triangle divides each median into two parts, so that the distance from the centroid to the vertex is blank the distance from the centroid. No, distance from the centroid to the vertex is blank this distance. Double. Twice.
In the end, we just apply to each other. That's how it goes. Wait, I can't read C15. Donald.
Double.
Double? Oh.
Yep.
Thank
Or
you.
twiki.
Wait, what?
Twitche.
I like Twitche.
Twitche. It's double or twitche.
Or etc.
Any questions? Now we have two more conjectures on the sheet, which we're going to do on Monday. And they're actually related to the construction portfolio that we're working on. So this is the first time I've done it this way, where we balance it first and then see if it is a concurrency point for medians. I usually have people construct the medians and then try to balance it on that point. And it never seemed to work out very well. This seemed to be all right.
That would have worked better. Like if we found the centroid first.
And try balancing it on that. You could always do that. I've done that before, and for some reason that people, when they do their constructions, their accuracy isn't as good as it could be. So it's always never quite in the right place.
It's more accurate with actual technique opposed to just trying to get it to balance.
Actual technique. Like what?
Actually knowing how to find this, like you know how to find the centroid, but you don't know exactly how to get it balanced. You can't make it balance.
Well, it should be if you use your compass and straight edge and make a very neat centroid using construction techniques.
Yeah.
Cut it out carefully, and if the density of the paper is uniform, then you should be able to balance it on that point without any effort at all. But it does depend on being very neat and careful about doing it.